My name is Mark Montminy. I'm a professor at the Salk Institute. Our laboratory studies fasting and feeding metabolism, and for some time we've thought about it much like a hybrid car. During the day we use high-octane glucose in the bloodstream to supply our muscles for activity, and at night we shift to burning fat, which provides a nice stable battery-like source of energy so that we can sort of keep basic functions of the body alive. And for most tissues that works just great, but there are a couple of tissues in the body, most notably the brain, that requires a constant supply of glucose in order to survive. And the liver has taken the role of providing that glucose. It actually starts being a glucose machine at night. And there's a specific genetic switch that we've been studying that's important in turning on glucose production in the liver. What happens to turn this switch off is that there are hormones in the body that start to circulate when you fast, and those are key in causing a chemical change in this genetic switch called phosphorylation. And once this phosphorylation occurs on the switch, it flips it on and the glucose comes out of the liver and supplies the brain. And about a year or so ago, Steve Kay at UCSD was studying how different signals regulate genetic switches and metabolism. He was interested in the biological clock. We all know that the time of day that we eat or fast has a lot to do with how well we feel. In fact, in shift workers, it's known that their disruptions in their biological clock makes them more likely to become obese and to get insulin resistance. So there was a lot ahead of time saying that something about the clock has an influence on how well the liver and other tissues work during the day or night to support fasting or feeding. What we found was that the biological clock actually influenced the ability of the liver to make glucose by altering the effect of fasting hormones on the phosphorylation of this switch. And we think that that will have important consequences in understanding why shift workers who have a disrupted clock often have higher incidence of obesity and insulin resistance. So I think that this is, an interesting start and hopefully will set us up for future studies.